So one thing you can do, we've done a lot of work with Julian, of course, and I, 3D printing various essential components for the MDRS, and also she's done a lot of with medical supplies. Now the thing is that a printer needs two things to function. It needs plastic and it needs electricity. Now we cannot create plastic out of thin air yet, but we can create electricity. It is surprisingly quick to rig up a solar charger for this thing. I've done it here with stuff that we had around. Of course, we had the solar panels, the batteries were recovered. You could even use a car battery if you have nothing else. The wiring was recovered, the meter was recovered, and you just do a very quick modification to the power supply for this guy to allow it to run on DC. So what I have outside is a very simplified sort of found materials solar charger for this thing, and we're gonna try to do a print with it. This is the thing. I put in a flower pot because portability is important. You want to be able to stay carry it around. Not a lot of wind today, so we're gonna have to sort it out. This is a surprisingly small amount of panels. However, assuming that they don't get blown up by the wind, which they might actually, so we may have to abort, this should work. This is one of the very many times in which having Velcro would be fantastic. Velcro is to hardware guys what Wi-Fi is to software guys. But let's see what we can see, okay? Now today is interesting because today is December the 22nd. So yesterday was the least sunny day of the year. So we're very much doing the worst case scenario here.
So if we can get it to work today?
Hopefully.
What does that mean?
It means that if it works in the worst time of the year for this, it will work in all the other times of the year. Which, you know, that's kind of nice when you're doing testing, because you want to make it hard on yourself in testing so that it's easy when people are actually using this thing in earnest. Now, these panels are on the shadows because I'm standing in front of them, of course. And what you would want to do at this latitude would actually be, if you have anything like a, like a wooden board or a washboard or anything flat, you put them on top of it. However, again, given the wind, we're going to have to work with what we have. So what I have here is a simple little modular adapter that I made. These things here are going to give us a nominal 27 volt at 3 watts. And 27 volt is nice because that printer in there is 24 volts, and these things are never going to give you full power if they're flat on the ground like that. So it should just about do the job. So what we got here is the little pail. That's a power supply, and this is the cord to the panels. As you can see, it's very thin. So let's wire this guy up real quick. Red to red, black to black, and I got some good news for you. I don't know if you saw the needle move set properly. So what we're gonna have to do here is take this pail back inside, and this is the original power cord for the printer. I am actually using the original power supply for the printer, AC power supply for the printer, as a regulator. It's right here. When this is all done, I will put it back to work on 110 volts, in fact. So the key thing here is that you're not breaking anything here. You're building something. You can take it all apart and you can get all your stuff back. When you're working with limited supplies, that's important, because today these panels are going to do the printer. Tomorrow they might do a water pump. Tomorrow, the next day they might do something else. So let's get this guy back inside. So what we do now, the thing that's important is, these little panels are not going to be able to run the printer by themselves. There's a battery in the middle. In fact, you could just run the printer off the battery. However, this is slightly more efficient, so we're going to do this. So what you do is you put the battery in the circuit, and there's gonna be a little spark. Don't freak out, okay? There's the regulator here has a capacitor, so there's gonna be a little spark. Don't panic. If there's a big spark, panic. And there wasn't even a little spark, which is actually kind of weird. Oh yeah, that's because I charged the capacitor with the panels. That worked out perfectly, actually. So, now this is my little power plant in the flower pot, and we're going to keep an eye on the voltage here. Make sure that needle stays nice in the middle. All you got to do now is hook this up to the printer like you would normally and hit print.
All right, here we go.
You want me to, or?
Sure, go ahead. Put it around in the back, and then,
Alright, let's see if I owe you a printer, huh?
well, you'll find out. Okay, great.
Do I owe you a printer?
Yeah.
I don't owe you a printer!
It's going to start printing.
Well, the voltage is about 25 volts. It's a bit too much, but you know, we'll take it.
Okay.
Now this is where the printer's heating up. That's actually the most expensive part of the process as far as energy goes. So once it does this, then it'll just use the little heater, and it's mostly smooth sailing out here. So what are we printing? I don't even know.
We're printing a finger splint. It should take less than 20 minutes.
Brilliant.
Yeah. How much time do you think we have to run this based on the solar
Well, with
panels?
those panels in this weather, I think you can, if you leave them out all day,
Yeah.
my back of the envelope estimate is that you can print for about 60 to 90 minutes a day.
Cool. Okay.
And you know, if you got a guy with a broken finger, that's sufficient to.
Yep. Well, hopefully we'll have enough time, and then we'll print you a splint for your finger. How does that sound? Your finger's just a little bit bigger than mine, so.
Yep. As long as you don't break it, please.
Yeah. Here we go.
It's good, thanks.
Yep. Looks good.
Okay.